And here I'm gonna share my screen. Okay, first one, I'm going to here talk about the balancing the chemical equations because um, in order to do this, mm, okay, yeah, right. In order to do other stoichiometric calculations, calculating the theoretical yield, percentage yield, the limiting reagent, we all must know, or we all should start with balancing an equation. So let's focus on these the techniques and the other stuff regarding this the balancing chemical equations. Okay. So when we are balancing the chemical equations, first of all, the first one is a very easy one since we have only two elements, sodium and bromine. So when this is the reactant side. Mm, This is the reactant side, and here is the product side. Okay, when you compare the amounts of these elements on both sides, you will see sodium has just equal amounts in the both sides. But when we look at this, the bromine that has two bromines in the reactant side. Therefore, we have to add 2 in front of or as a coefficient for the sodium bromide. There is no other way to match up the bromines, the number of bromines with the reactant side. Since we add the 2 in front of sodium bromide, that makes 2 sodiums as well in the product side. Therefore, we have to add 2 as the coefficient for sodium as well. So that's how we balance that equation. Questions. Right. Okay. The next one. We'll go to the equation in between aluminum and oxygen making the alumina, Al2O3. So when you look at this, you will see that aluminum in here has 2. So we may start with 2 in front of the aluminum on the other side. But when you look at the oxygen, oh, okay. The oxygen has 3 moles, 3 oxygens in the product side. But in the reactant side, we have 2. So we should now bring a common number to balance out the oxygens. So if I put 1, no other way I can make it to equal. But if I put 2, no, it doesn't make sense again. 2 by 2, 4, but it's still 3. No, it will not be equal. But if I add 3, then this would become 6 oxygen. Then the product side has only 3. How can we make it equal to 6? Yes. So I should add the number 2 as the coefficient. Right. Since I added 2 in front of Al2O3, that makes the aluminum total as 4. So now I have to delete the number 2 in front of aluminum and make it into 4. Questions. When we are balancing these equations, we should try to use the smallest ratio in between the elements and substances. Okay, next one. We'll go to the next equation. P4N P4NO, P4O6, and N2. Right. In here we have 4 phosphorus. The other side also have, the product side has 4 phosphorus. Okay. But the oxygens, we have 6 oxygens. Okay. Then I have to add the 6 in front of that. Since I had added 6 over there, makes the uh, nitrogens equal to 6. So I should add, I have 2 here, so I should add 3. 3 by 2 will equal to 6. Okay. Now let's see. 4 phosphorus, good. Both sides have 4 phosphorus. 6 nitrogens, yes, good. And 6 oxygens. Nice. Okay. Questions? Okay. The next equation, that is the burning or combustion equation. We call it a combustion equation when an organic compound is burned with oxygen, that will, when it is a complete combustion, complete burning of that organic compound, we will only get carbon dioxide and water. That is, this type of reaction is called a combustion reaction. Right. Okay. In the balancing these type of equation, we first balance it's the carbons. Okay. Now we have 4 carbons in the reactant side. So I will add 4 in front of the carbon dioxide. Right. So and I have 10 hydrogen in the hydrocarbon, but in the water molecule has only 2. So how can I equal to 10? So I have to multiply that 2 hydrogens by 5 to make it equal to 10. Now let's count the total number of oxygens in the product side. With 4 carbon dioxide molecules, it brings 8 oxygens. With the um, the 5 water molecules, it brings 5. Okay. So what's going on now? Yes, we have 13 oxygens, right? So the here we have to add the 13 here, but it it didn't if I get that, it should be 13 divided by 2. Why? There is 2 by 2, but you don't have to divide by 2. So what you should do, you should multiply all other things by 2, since I don't want to put a fraction there. And here will be 10 water molecules. And now I can erase the 2 in here. Is it clear? Okay, we'll go to the next one. Sodium tetra, okay, tetrafluoro boron, right? So when we look at this, right, I have one sodium, one boron, 4 fluorines, but here 1 and 1, I have only 2. Right. So, but here also I have 2 hydrogens, but in all together in the product side I have 4 hydrogens, right? So what should I do? I have 4 hydrogens, so let's add the 2 here. Is it going to be equal? No. Why? The product side has 3 in front of that. So what should I do? Yes. Now I can. I cannot. I have to find a common number that would be equal to 2. If you put 2 in front of that, then I will have 6 oxygens there. So then I'll add the 6 over here for the water molecules. Right. So now, mm, right. So now I have 6 water molecules and, sorry, 12 hydrogens. And how about the hydrogens in this case? 6. Here this brings 6. And there I should add another 6 over there. Understand? Right. Okay. Now, what's going to be the next thing I should do? Um, I will add. Now I have 6 here and 6 hydrogen, so it's going to be 12. Right. So I balance the number of hydrogens and oxygens. But how about the fluorines? Right. Now I have boron, 2 borons here. So if I add 2 over here, okay, so this is going to be like a trial and error method. You have to start with the smallest number and eventually you can go up until you will find the balance. So I have 2 and 2, okay. 2 sodium, 2 sodium. So how many fluorines in the reactant side? 2 by 4, 8. And how about the fluorines in the product side? Yes, 2 and 6, 8. Good. Is it balanced? Now, yeah, seems like it is balanced. Any questions? Okay, I'll move to the next one. BF3 with lithium aluminum hydride goes to B2H6 and lithium fluoride and the ALF3. Right. So if when I start with this, look, this product has 2 borons, but the reactant side has only 1 boron. So I'll start with that. I'll put 2 in front of the BF3. When I put 2 in front of BF3, let's see how many fluorines I bring here. It's going to be 6. Here I have 3 and I will add another 3 here. Uh, what would happen? Nope, right? It will not match that way. Oh, here we have 4 hydrogens and this side has 6. So what is the common number that I can bring to balance out these hydrogens, 4 and 6? Let's make it to 12, the total 12. Then I have to add 2 in here and then 3 over there. Right. Let's see then whether we can balance this out. I'll erase that part. Why? Because now I have 4 borons. Okay. Right. It's gonna be 3. Okay. Since I have 3 aluminums. Okay. 3. And here 3 aluminums. Okay. Here. Right. Now, is that balanced? Let's count the fluorines in the product side. Here I have 3 and 3 plus 3 by 3 equals to E, 12, right? So fluorines are balanced. The reactant side has 4 borons, and the product side also has have 4 borons. Yes, 3 aluminums, 3 lithium, and 3 lithium. Okay. Questions. Next one. Mm, silicon tetrafluoride, H2O, H4 SiO4, and H2 Si F6. Okay, right. So here I have 4 hydrogen in this side and 2. So it's gonna be equal to 6 altogether. So let's start with adding 2, uh, 3 here. Okay. But then again these 2 has 1 silicon each. So I have to add 2 on here. Right. So let's count the number of fluorines in the reactant side. It will be 8. And here, I'll have only 6 fluorines. So that number doesn't make sense. Right. So I should find a common number that may equal, that could be the a common number for the 6 and 4 again. What could be the smallest number that can be a fraction of 6 and 4? Yes, 12, right? Okay. So when I want to make it to 12, I should have 3 in front of that, and here I must have 2. Oh, okay, right. So then I will have 3 fluorines. I have 3 fluorines in the reactant side, 3 silicons, I'm sorry, 3 silicons in the reactant side, and the product side has 1 and 2 equals to 3. Very good. So fluorines equals to 12. Here, yes, now fluorines are also balanced. Now, let's count the oxygens. 4 oxygens should be there. So what should I add here? Yes, I must add 4 over there. Right. Then it makes 8 hydrogens. Yes, 4 plus 4 equals 8. 4 plus 4 equals 8. Yes, so that is balanced. Questions. Okay, we'll move to the next one. Right. Here we have 1 sulfur, 2H2, good. But here I have 4, okay, 5 oxygens. Okay. So I should, if I add over here, then it would be equal, right? 1, 1, 1. But I shouldn't add it as a fraction. So what should I do? I should multiply the other everything by 2. When I multiply that by 2, the 2 to 2 will cancel out. And I'll get only 1. Right. Let's see now, is it balanced? 2 sulfur on the reactant side, 2 sulfur on the product side. 4 oxygen plus 2, 6. 6 plus 2, 8. Yes, oxygens are now equals to 8 on the both sides. And hydrogens, in the reactant side, I have 4 hydrogens. And here also I have 4 hydrogens. Right. Questions. Okay. The next one. Again, this is an example of a combustion reaction. Now I have 3 carbons in the reactant side, so I'll add 3 over there, and that makes 4 hydrogens, but here I have how many hydrogens in the reactant side? 8. So I must have 4 oxygens. Sorry, 8. No. 4. Yeah, that's right. 4 oxygens, then 4 by 2 equals to 8. Right. So then how many oxygens? 4 plus 3 by 2, 6, 10. Therefore, this should be 5. Okay. Questions? Right. We'll move to the next one. Copper hydroxide and phosphoric acid gives the copper phosphate and H2O. Right. So this case, the product side has 3 copper atoms. So
Wait,
we yes.
on number 9, the one you
Yes.
just did, I believe you have 11 oxygens on the left side and 10 on the right. Unless if I'm counting wrong.
Hydrogens? Oh, oxygen.
Oxygens.
Oh, yes. Thank you for bringing it up. Yeah.
Mm-hmm.
Okay, yes. Here I missed that oxygen there. Yes, thank you for bringing. So now I have lemon. Yes. So what can I do? So I can add the 2 in front of this. Okay. So if I add 2 there, mm, the number of oxygens on the side, reactant side, will be 12. And the product side, let's see the product side, 6 and 4, 10. But if I'm gonna add then I will be having 6 carbons that side, right? Okay, let's start it from the beginning. Okay, yes, 4. Okay, I'll add the 3 here, and that makes the 7 plus 8. So here is the thing what I start with. But then I have here 6 oxygens plus 4, right? 10. But the other side has only um, 3 oxygens, the reactant side. Okay. So in order to make this equal to 10, then I have to add this, right? 9. If I add 9 over 2, then 9 plus 1 would be equal to 10. But I don't want to add it as a fraction, so I'll multiply that the everything by 2. Here 2, and then 3 by 2 would be equal to 6, and 4 by 2 would be equal to 8. Okay, so let's see then whether this will be the equal to both sides. Is that correct now? Let's count the number of oxygens in the uh, product side. 6 by 2 equals to 12, and 8 will be equal to 20. Right, the reactant side, 2, and 9 times 2 would be 18. So, yeah, then the oxygens will be equal in both sides. Okay. Yeah, thank you so much for bringing that up. Yeah, okay. Any other questions? Okay, we'll move to the next one. Right, we have 3 coppers in the product side, so I'll start with 3 in front of the copper on the reactant side. Okay. And here I have 2 phosphorus. Why? Here you will see these parentheses on or covering the PO4 by 2. That means I have 2 phosphorus, right? Okay. Now, how many oxygens on the product side? Here, oxygens equals to 4 by 2 plus 1 equals to 9. But in the reactant side, because now I feel like the reactant side, we have added the coefficients for everything on the reactant side. So let's count the oxygens on the reactant side. So that would be 2 oxygens multiplied by 3 plus 2 by 4. Right. So 6 plus 8 would be equal to 14. But now in this side I have only 8, 8, right? 14 minus 8 will be 6. So I'll add the 3 over here. Right. Now let's now see if hydrogens are balanced on both sides. Right. Hydrogens on the reactant side, 2 by 3, 6 plus 2 by 3, 6. So altogether I have 12 hydrogens. In this side, no, the hydrogens are not balanced. Yes. Yeah, hydrogens are not balanced. What should we do? We have to bring that up. Okay. Let me clear the area. Okay. So now we have the hydrogen in the reactant side, we have 12, but the product side, we have only hydrogens 2. So I must add the 6, right? This is going to be like back and forth. Yeah, I'm thinking why I added it such a big number there. Yes. Let's see. Did I count the hydrogens wrong here? Or the oxygens wrong? Okay. 2 by 3. 6 plus 4 and 2, 8. Oh, okay. It's 14. Right. Oxygens are 14 on the other side. Then this side I have oxygens 8. So I must have 3. 6. Oh, okay. Because it should be 6. Is it correct now? Yeah. Okay. Right. Okay, I'm gonna stop the recording now. Right. Yeah.